Okay, this is going to be the first video in a playlist about chemical thermodynamics. So this is going to deal with the first semester of physical chemistry, of undergraduate physical chemistry. So if you're an undergrad, this will be pretty useful for review. Although it's not going to be like complete lecture. It's just going to be review of some topics that you'll probably find in your book. So we're going to start with the properties or some properties of the total differential. So we're going to consider continuous and differentiable functions on a simply connected region. The necessary condition for the differential form dz is equal to the function m, which is a function of x and y, dx, plus n, which is another function of x and y, dy. And this is a total differential of our function z, and z is a function of x and y. And the necessary condition for us to be able to write this in this differential form, so to write the total differential of z, is that we have the partial of m with respect to y at constant x has to be equal to the partial of this function n with respect to x at constant y. And this is something that has to hold true at all points of the region. And we also have here, we have additional definitions. So we have that m is equal to the partial of z with respect to x at constant y, and n is equal to the partial of z with respect to y at constant x. Okay, so we have here that henceforth the total differential of the function z, and z is a function of x and y, it holds that dz is equal to the partial of z with respect to x constant y dx plus the partial of z with respect to y at constant x dy. So in other words, what we're saying here is that the mixed second derivative of the function z, that's got to be equal. So it doesn't matter if we take the derivative of z with respect to x first and then do the partial with respect to y after that, and we get a second derivative, or if we do the partial of dz with respect to y first, and then we take it with respect to x, we should have the same result. That's what we're saying here, okay? So in the next video, we're going to do an example. We're going to do an example with just numbers and variables that have nothing to do with chemical thermodynamics, and then we're going to start looking at the connection of this concept to state functions. Okay, so that's going to come up in the next two videos. I'm going to look at we're just going to do a pure mathematical exercise in the next video, and then after that one, we're going to look at state functions.